All right, so today there's only one topic. We're going to be looking at integrals of even and odd functions. So before we even get started, can anybody explain to me what an even function is? Doesn't have to be mathematical, could be kind of graphical, pictorial. S?
When f of x is equal to negative f of x? Or f of
That'd be odd, yeah. So really the way to say that statement is f of negative x equals f of x. I mean, that's the mathematical definition. How about pictorially? Can someone tell me pictorially? Yeah, Leila.
Symmetrical across the y-axis.
Symmetric about the y-axis, thank you. Okay, and for odd?
About the origin.
Nice, good job, yes. About the origin, good job. Okay, so you know that this first integral that you have here, this one here, you know that this represents the area underneath a curve, right? Because that's what integrals are. And so here's my function, fx equals x squared. And the integral is asking you to find the area underneath the curve and the x-axis between -2 and +2. So notice that the curve satisfies the definition of Leila for symmetric about the y-axis. What do you notice about the two blue shaded, or what do you think is happening to the blue shaded areas? What do you think the relationship is? They are equal. Okay, they are equal. So I can rewrite this as equal to 2 times x squared dx from 0 to 2. Okay? All right, and you know that this is then equal to 2 x cubed over 3, 2 to 0, and so that gives me 16 over 3. Can you do this problem on your n box and see that you get this answer? Sorry? Yes. So the property we're going to use is this property here, that if you've got the area underneath, underneath an even function, and if the limits of integration are symmetric about the origin, then all you need to do is find one area, and double it. Okay, find one area and double it. Okay. The next problem we're going to do is the odd function. Okay. So according to S, odd function is symmetric about the origin. And so this function looks like this. And the problem's asking you to find the two areas. What do you think the answer is going to be?
0.
Whoa! Everybody with Henry on that. Why 0, Henry? He's such a show-off, man. Aren't you guys getting fed up of that guy there? Do you get the message that nobody really, Henry, cares about your abilities?
Secretly, myself as well.
Yeah, right.
You know you like math.
Laura, question.
Oh no, I was just saying half the time he shouts out like gibberish, so it really doesn't impress me when he shouts out words.
Oh, is that okay? I guess yeah. All right, that kind of makes sense. All right, so do you guys know that this area here is going to be negative because it's underneath the x-axis? Okay, and on the other side it's going to be positive. They are both equal, so it should be equal to 0. Okay, your answer is equal to 0. Oh, wow. Yeah, Monica's getting to the math now. Yeah, after about a year, she's getting there. IST. Better late than never. Okay, can you verify this on your n box? Okay, do this on your n box and verify that. Yeah? Right? Okay, so then what I'm going to give you is just a box that gives you the two properties, okay? So if the function's even, you need to find only one part of the area and double it. If it's odd, then your answer is always 0. All right, you guys okay on that? All right, you guys got this okay? Yep. Okay, one example and then we are done. Okay, so page 306, number 103. Okay, so if you read the instructions in there, it tells you evaluate the integral using properties of even and odd functions, okay? Properties of even and odd functions. So I'm doing number 103, okay? So to begin with, can you guys tell me what do you think sine squared x cosine x is? Is it even or odd? Sorry? Tell me why.
It starts at 0 for y value.
Why don't you think about the symmetry? Why don't you think about sine squared? Is that an even function or an odd function? Sine squared. What's x squared? What's x squared is even. Sine squared is going to be even. Okay? You square a function, it's going to be even. Cosine, even or odd? Even. Cosine is an even function. Okay? You guys know, you have to know your graphs, okay? So you know cosine goes like that. Okay? So it's symmetric about the y-axis. So sine squared is even, cosine is even. What do you think sine squared x, cosine x is going to be? It's going to be even as well. Right? It's got to be even as well. If you're in doubt, what would you do? Graph it. See if it's symmetric about the y-axis, okay? So then the question requires you to use the properties of integrals of even and odd functions. So this guy becomes 2 times 0 to pi over 2 sine squared x cosine x dx. Okay. What do you do next? Sorry? U sub? What do you want to do U sub? How about just sine x equals u? Yeah, sine squared x would be a bad choice. Okay, so I don't know if you realize this or not, that in U sub, if you make the wrong choice, yes, you are fried. Okay, you are fried. So, cosine x dx equals du. Is everybody with me on that? So notice that you've got cosine x dx right here, and you have it right there. So what you're going to do is you're going to take this du and put it in place here. Okay, so then this guy becomes 2 du. And in place of sine squared x, you're going to write u squared. Now what about the limits? What about the limits? Should they be pi over 2 and 0? Should they be pi over 2 and 0? Why, Henry? Explain why. Okay, let me ask you this question, okay? These limits are pertaining to what variable? X. We can see it right there. That's your variable. What's your variable in this integral? U. Is an X a U? Is a Zara a Sajal? No. No. Okay. All right. So you cannot use pi over 2 and 0 because they're two different beasts. Okay. Are you a beast? Yeah. Okay. Then what you do is you come back here and you say, all right, I know that X is pi over 2. What is sine pi over 2? What's sine pi over 2? Hello? 1. And then you put 0 in here. And what's sine of 0? What that? He's trying to say a 1 and a 0. Between a 1 and a 0. 0? Okay, it's a 0. Okay, it's a 0. Well, you know how to integrate u squared. And you plug and chug 1, 0. What do you get? Two-thirds. Can you n-box the original equation? That's this one here, and see that you get 2 over 3. Okay? Is everybody all right? Any questions here?